There we go. So yeah, if anyone is not okay with their face being recorded, please turn your camera off. Otherwise, you're welcome to turn it on or turn your mic on. Oh, I'm really happy with the results of this poll. Looks like around, not everyone has responded yet, but looks like around 88% of our audience is first-year students, which makes me really happy because I made the material catered to thinking first-year people would be the one joining the most. So I'm really happy about that. Okay, 2 more people. Actually, one of them might be Brian, who hasn't answered. So one, okay, there we go. And poll. I will be, actually, there's not a lot of coding in this. There's a bit of coding at the end, but the coding at the end is Python. Okay, so that's the results of the poll if you're curious. The second poll I wanted to do is your experience with competitive programming. So there are a couple of options. Before you pick, let me explain. Zero experience means just you've never even heard of it, never thought about it, just don't know what it is. Limited experience is like you've heard of it, done like really easy questions like A plus B, and you just know what it is, but interested to learn more. Pretty good means like you've done like a couple of contests, but like don't know all the algorithms and stuff. And expert means you just know everything. Like you could do this workshop instead of me. Oh, wow, there's a pretty good distribution. And by like normal distribution. 5 people. Can you all see my screen? Perfect. Okay, looks like most people have answered the poll. Here are the results if you're interested. Again, pretty good. Limited experience makes sense. Otherwise, I don't think you would have come to this workshop. But a lot of you have like pretty good experience as well. Okay. Let me see. Two more minutes. Let's do another poll. Promise this is the last one. So the one person that chose expert broke the symmetry. Yeah, they really did. Is MCSS a club? Yeah, Brian's answer. Cool. So today's workshop is going to start not with score decomp, but it will build up to it. And so I'm just curious how many of you know it. Okay, 6 more people left to answer. Cool. I just know some optimization algorithm. Correct. In fact, everything or most things in competitive programming are some sort of optimization. Like most problems have a naive solution. And so you just want to look for a way to solve them better. Okay, so most people haven't heard of it. That's great because I am going to kind of get there. Here are the results if you're curious. And looks like it's 7:10 as well. So we can start with UTM time. It's perfect. This is MCSS's first competitive programming workshop. And if you keep doing them, maybe you'll have a streak or something of attending. Okay, a couple of disclaimers. This is informal. It's not like this material that I made isn't approved by some prof or something, although I am pretty confident in what I wrote. But you should definitely not use it in courses and stuff, because I definitely, like in competitive programming in general, things are worded differently than you would use in a course, especially regarding time complexity, which if you don't know what that is, it's okay, I will explain later. So let's just dive into it. We're gonna do a fun problem. Suppose you're given a list L of length n as input. What does that mean? In terms of Python, I'm guessing most of you are taking CSC 108. Something like this, like 1, 2, 4, 6, -1, etc. And so n here would be 6. And let's say you're given two indices, for example, 0 and 3. So L equal to 0, R equal to 3. And what you want to find is the sum of every element in between. So that would be here. Can we use sum, or do we need to use an accumulator? You could use sum, but what I'll explain there is that is not different from you doing an accumulator in terms of like the code being efficient. For loop from L to R. Yeah, that sounds reasonable. Just go from L to R. Again, I'm just not writing formal code or Python code. I'm just writing something you'll be able to understand. Oops. And then sum would be your answer. So that's not too bad. Now let's say it's a bit more complicated. Suppose you're again given the same list. Shouldn't sum be declared before the for loop? Yes, if you're writing code, or even if you're like writing proper pseudocode, but yeah, you're right. I should define sum to be 0 here. Yeah, it's just pseudocode, which I'll explain what that is also, but yeah, you're right. I should have defined that. Okay, suppose you're again given a list of length length n. And this time, instead of just asking for the sum of something between L and R, it repeats this query some number of times. As an example, let's say L is equal to 1, 2, 3, 4, 5, which means that n is 5, and you're given 3 queries. First query says, what is the sum between 0 and 1? What is the sum between 3 and 4? And what is the sum between 0 and 5? So the answer that you want to give is for each of these, you want to say, what is the result of this? What is the result of this? What is the result of this? So for this, the answer is 1 plus 2, which is 3. The answer for this is 4 plus 5, which is 9. And I chose an invalid index here, my bad. Let's make that 4. And I think that's 15. And so what you want to return is these 3 numbers. So it would be like a 2D array. Okay, let's explore that idea. What would you store in your 2D array? Oh, the M queries. Sure, yeah. To be fair, you don't really need to store the number of the query or the INJ. What you can do is do some stuff to read the list, and yeah, do a for loop I don't know, from J. And then here you can do read one query, print answer, right? Because queries are completely independent of each other. So you don't have to actually store each query. You can just process the query on the spot, print the answer, move on. Of course, it's totally fine to keep it in a 2D array if you want. It just takes up more memory. Yeah, I was gonna ask, are we given a tuple with ranges? Yeah. So your inputs for each query are two indices, L and R. The reason you say L and R, like similar to this problem. L stands for left, aka left of the range. R stands for right, aka the right of the range. And by convention, it's you're supposed to do it inclusive, aka include both of them. Similar to what we did here. You want the same value. Okay. So does it make sense why you don't need to save all the queries in a 2D array? I forgot to ask that question. No, I was asking if M would be inputted as a 2D array. So the input is, oh shoot, this is, I think, something that CSC 108 maybe doesn't cover that well. But you know that you can write a program and enter something in the console and print enter, and it would, the program can read that value. So I guess let me make an additional slide here. So this is something called standard, I guess I should have explained this, standard input output. This means that instead of you needing to write a function that takes inputs and satisfies this, you write a program that takes input from a user who's typing behind the computer, using like input or something, exactly. Input for reading standard input, and printf, print, which you should already be familiar with, for standard output. You will see what this means. Yeah, exactly. I totally forget that 108 doesn't explain that how to do a standard input. I'm so sorry. Okay, cool. So back to here. Now that we know how this is all processed, how would you go about answering this question? Don't worry about making it efficient or anything, just say the first thing that comes to your mind. Have one function that calculates the sum. For loops would be slow since the length could be long. Yeah, but don't worry about slowness for now. Assume our computer is really powerful or something, like your NASA. And that's it for loop, good. So here you can do what you did last time, for I from L to R, and then sum it up. And then you can print sum. This gives you the answer. Can you kind of intuitively tell me about how many operations this does? Okay, let's not use super confusing notation yet, but yeah, you're correct. Actually, you're not exactly correct. So reading the list is about n operations because there are n things in our list, right? Everyone cool with that? And then here you do about M operations inside, you do the stuff inside M times. And what is the stuff inside? This is one thing, this is one thing, this is one thing, and this is R minus L things. So since we don't know what R minus L is, we're just gonna take an upper bound, because let's say the user is really stupid and mean, and every time they're just querying the whole array. And if they're querying the whole array, this could be n times. So in total, it would be n for reading the list, and then m times 1 plus 1 plus n plus 1. Kind of, like approximate. Which a lot of people are noticing can be simplified to mn. Don't worry if you don't know why, I will explain later. Okay, now let's say oops, I shouldn't have went to the next slide. I hope you didn't see. Now let's say we want to optimize this a little bit. And we don't want to do a for loop each time. Does anything come to mind as to what to do? Lots of different ways you can do this, by the way. You can have just one for loop. Can you elaborate on that? Okay. And how do you answer each query? So let's write. Let's say we read input, which we know takes about n times. And we loop over queries. One loop for the list of numbers and ask for the queue of queries. Can you explain your thought process? Because I don't really understand. Also, feel free to unmute yourself if you don't mind being recorded. Sum is equal to list query m plus list query m plus 1. Okay, so the queries are completely independent of each other. So if you're given n queries like the example that I gave, here, the answer of this doesn't affect the answer of this. So it doesn't make sense to add this to this or anything like that. And if that's a typo and you meant adding list at this plus list at this, okay. What if the value is like the range is bigger than 2? For example, in this example, you aren't just adding the one at 0 and the one at 4. You're adding all 5 elements. Right. It's a range. I think for the sum of the range. Okay. So that didn't quite work. We can scrap that idea. You can try indexing and create a new list and then doing sum on it. You could try indexing and create a new list. We could use recursion. Can both of you explain what you mean? Like you index list, good, that works. The slight problem is list L plus R, L colon R. What do you think it does? It just for loops from L to R, makes a new list, gives it to you. So it's not actually any different from the original program we wrote in terms of efficiency. Create a function to add to the sum until you reach the base case. So you basically want to do the for loop recursively. You guys don't know how to prove how long a recursive call takes, but I can tell you that also is doing the exact same thing, because let's say you're saying start at R, then add R minus 1, then add R minus 2, blah, 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 until you reach L. That is still doing n operations. So you somehow want to find the sum in less operations. When in doubt, use a hash map. Good, you could use a hash map. How? Slicing still takes n time. And so, yeah. Same with what Maximiliano typed. That is still n times, because you have for I and then for j, which I assume is the range of the query. Oh, no, I think I'm misreading what you said. Right, no, I'm not misreading. Yeah, that's doing the exact same thing as before. Okay, in the interest of time, I'm gonna explain the hash map. It's not really an optimization, but it's interesting, so I will talk about it. What you could do is pre-calculate the sum of every two, basically from any range to any range. So you read input from L, sorry, for I from 0 to n, for j from I to n, put the sum, basically use the sum thing that you guys really love. And put it in some hash map. Okay. It doesn't matter. No dictionaries. Just think of it as a 2D array. So now you can do for all queries. You can return or print H at L and R. Cool. Does this make sense to everyone? Basically, pre-calculate the sum of any range before the queries even start. And then once the queries start, then just give that range. So the order or the how long this takes. Also, this shouldn't be indented. So how long this takes? This is n operations. This is n squared. But actually it's n cubed, because the sum is also taking on itself. I hope that makes sense. And then this is just m, because each query can be answered with just one operation. So the total number of operations is something like this, which isn't, it might not look better than nm, but depending on what you know, no, it would be, if you want to think about it in O, it would be n cubed plus m. You can't just discard a variable. So it might not look much better than nm, or in fact, any better at all. This depends on which one is bigger. Is n the one that's bigger or m the one that's bigger? Are they equal? It depends on your input. So if you have a really short list, the highest degree of the same variable. So you don't care about n because n cubed is here, but we know nothing about m. So yeah, depending on which one's bigger, you might want to do one over the other. Okay. Here's an idea. There's something called a prefix sum array. Call it psum from now on. I say define an array psum for psum I. Put this calculation inside of it. Just the sum of the first element till the last element. Sorry, the second, like the one before it. So if you have an example 1, 2, 3, 4, 5, then psum at 2 would be the one at 0 plus the one at 1. So it would be 3. Now, if you think about it, we can calculate the sum of what we originally wanted. So if you want to calculate L at small l plus blah, 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 plus L at R, now you know psum of R and R plus 1 also. So psum of R plus 1 is L at 0, L at 1, blah, 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 L at R, and psum of L is L at 0 plus blah, 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 plus L at L minus 1. What happens when you subtract these two?
You just get left with L, like the sum from L onwards.
Exactly. You're exactly left with what you want. Why? Because when you subtract these two, this cancels with this cancels with this, and blah, 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 and this cancels. So all you're left with is the sum that you want. Does everyone agree with this? L minus 1 to R. Not quite, because L minus 1 appears here as well, and it appears here as well. So it gets canceled, but L doesn't appear. R plus 1, because it's non-inclusive. So we define the psum I to only include till I minus 1. Yeah, cool. So that's pretty efficient. Before we get into how efficient it is, I want you to know that there's a couple of things you care about in competitive programming. Whenever you're given a question in a contest or like a practice, they give you the exact format of your input output. For example, they say the list is going to be given in this way by the user. The queries are going to be given this way by the user. N is going to be exactly between these values. M is going to be exactly between these values, and blah, 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 blah. And if you're not given a constraint, it just means you're not allowed to assume anything about that variable. And unlike in school, you don't need to do any error checking, because in a contest and practice problem, you're guaranteed to be given valid input. So there's your input. In terms of your answer, it needs to do a couple things. Obviously, I did not mention this, but it needs to be correct. It needs to give the right answer. And on top of being correct, which is the most important thing, it needs to be it needs to give the answer in an efficient manner. And it should not use too much memory. What does memory mean? For example, I mentioned the hash table solution, which had a 2D array. Maybe that's really big and we can't keep track of that. So maybe that solution wouldn't work for this problem. We're not going to talk too much about memory. this time because it's usually not that big of a deal. That's measured in space complexity, correct. So this is time complexity. They just like to give fancy names for everything. Okay, so both important, but right now I want to explain it is space, maybe later workshop. So every problem this year will show you these constraints. To be able to know, it's very important to know time complexity because you should be good at whether your solution will like work for that problem before you write the code, because writing the code might waste a lot of time. You write it, you need to debug it, blah, 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 blah. And then you submit it and it's like, oh, time limit exceeded at test 3. And you're like, well, I could have avoided that if I just knew how to know my time complexity. So you guys seem pretty good at that. You were able to tell that something like that programs we made were mn or n cubed plus m and blah, blah, blah. So that's how you calculate the number of steps that your program executes. But what you need to know is, okay, will this execute in 30 seconds? Like, they're not going to tell you your program needs to be n squared, right? They're not going to tell you that because that's like gives away the solution sometimes. They're going to tell you your program needs to pass in 30 seconds, like give the answer. So a rule of thumb is to assume your program can do this many operations. I have no idea how right this is. It's just what I was told, I don't know, 7 years ago by my teachers, and then 7 years ago to their teachers, and so on and so forth. But it's worked out for me, so it is what it is. Comes handy in courses for me because I can also use to make sure my solutions are sometimes like fast. But again, never like refer to this in courses. Like profs will look at you weird. Like, how do you like? What is this? Anyways, so how can you use this? For example, mn. Assume we were given that m was between 10 to the 5 and 1, and n was between 1 and 10. Then mn is about 10 to the 6. And when you divide that by 3 times 10 to the 8, that's going to be less than or equal to 0.01. So if like the time limit is like 1 second, you're really fast. Could we use a module for getting the time, like time the perf counter? Well, that means you'd first need to write the solution. And the whole idea behind this is think about how long your solution would take before you write the solution. Does that make sense? But of course, you can use that afterwards to like see how fast it runs or like how correct your calculations were. Maybe you can even optimize for this value and tell me if there's like a better, more accurate value. Also, it depends sometimes on your operations as well. Like if your operations are like bitwise operations or like sum and subtract, which are usually pretty fast, versus if they're like division or modulo, it's going to be different. Division, modulo, really inefficient. But yeah, general rule of thumb, it works for now. Okay. You guys, we went over this, so I won't go over too much. But basically, we don't care about the exact number of operations. Like I said, for example, we had a R minus L operations, but I just said, okay, let's assume this is N, because you only care about the upper bound. Like in the worst case, we want our solution to pass. We don't care if it in the best case it passes. Of course, if you're just going to give it a list of length 1 and 1 query, it's going to work. But if the user gives something big, will it work? And this upper bound is usually called big O band or big O, and it's shown with big O notation. So that's why people in chat were typing mn or like n cubed plus m. Second thing you need to know is you don't care about constants. The idea is if you're doing n squared plus 1 operations, if n is really big, it doesn't matter that you're doing this one operation. Like a really good example that my profs use that I really love is, for example, suppose n is really big, and suppose you're a millionaire, like you're really rich, you have lots of money, and someone gives you $1. But do you care about that $1? no one cares about, no millionaire cares about $1. So it's fine. You care about it. Are you a millionaire? Okay. Yeah, if you have $1, you care about $1. But if you have n squared dollars and n can be like 10 to the 5, you don't care. Of course, if you want to get a more accurate time, like if your solution is like the constraint is like 3 seconds and your solution takes 3.1, then you're going to care about those constants because you'll be like, okay, I need to like be as efficient as I want because maybe there's no better solution, but if I make mine efficient, it works. Similarly, we don't care about 2 times, like if you have, this might be less intuitive with that example of millionaires, but again, we say that 2n, n, and like n divided by 3, for example, are all the same-ish value. They all take O(n). So you can just use this to simplify your calculations. Of course, if you want to be exact, feel free, it's just harder. Is everyone following so far? I'm doing my best too. Okay. Let me, let's take like a 30-second break so I can make a new poll. Okay. Okay, there we go. Fill that poll out. Is there a certain equation we can use to get the big O time? No, there's nothing you can use to get the big O time of a code. That would be ridiculously overpowered.
So sorry, continue. I just had a question that came to mind.
No worries. I'll answer and then you can ask. So there's nothing that like calculates how what's the O of your code. You have to do it yourself. But if you have a guess for it, there are ways to prove it. And the formal definition of limits is using formal definition of big O uses limits. And you will actually learn this in CSE 236 in second year. Okay, go ahead.
So for time complexity, it like basically it matters only if like it n operations is like if it's done like exponential, right? So because if it's like just n or 2, and then it's like still in the long, like on a large scale, it takes roughly the same amount of time. But when it's like exponential, that's when we start to see.
Not quite exponential. Just if it's a function in terms of n. For example, 2 is a constant function.
Yeah.
1/3 times n. 1/3 is a constant function. But if you have something like n log n, it's true that log n is really smaller than n, but you can't just be like, oh, log n doesn't exist. Why? Because if you make n really, 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 really big, log n could be really, 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 really big. But in terms of if you have a constant, such as 1, 2, 1/3, and stuff like that, then you don't have to ignore it. You can ignore it. There's a caveat to this in competitive programming versus not competitive programming. In competitive programming, you can ignore small constants, but if you have something like 1,000 times n, in math, in computer science, you ignore this 1,000 because by its formal definition, if n is big, 1,000 can be ignored. But in competitive programming, your constraints are really limiting. And so if you have 1,000 operations times n, you do care about that 1,000. Okay. So yeah, exactly. Not something that has a variable in it. So yeah, same thing with like if you have n plus n squared, again, you can ignore n because in terms of n squared, n can be really small. This is not super important. Yeah, I mentioned that, I hope. It's not super important, but it's good to keep in mind. Okay, so let's do the p-sum solution. So the way I explained we do p-sum is we make p-sum to be the sum from L0 to Li minus 1, or p-sum of I. And so this is exactly what it's doing here. But notice how I'm doing it. Instead of every time, instead of doing 2 for loops and calculating p-sum from scratch, I use the previous p-sum, which I know it has to be L0 to Li minus 2. And then, sorry, L0 to, I may have made a typo here. I think this should be I minus 1. Yeah. This says, so you know that p-sum of I minus 1 is this value. And so if you add LF I minus 1 to it, you will get the correct value of p-sum. I know that was like not super helpful, so let me rewrite it. So you know p-sum of 0 is 0. You can look at the code and just see that p-sum of I would be, sorry, p-sum of 1 would be L at 0, and so on. And when you're filling out p-sum of L, you know that in the previous iteration, p-sum of L, I minus 1 was set to L at 0 all the way to L at I minus 2. And so to calculate the p-sum that you want to calculate, you just need to add this previous equation that we have plus the current I minus 1. Does this make sense? Intuitively speaking. Okay, this is something called dynamic programming, a really simple question version of that. But it can actually be proved using induction. In fact, it might remind you of induction because this seems like the base case. And if you assume that this holds, you can show that this holds. Does that seem familiar? Okay. Now, we know from the previous slide that each query can be answered O1 because it's just subtracting 2 p-sum values, p-sum of R plus 1 minus p-sum of I. And so in total, we're doing O of n plus n because we read the input On, we calculate the p-sum On here. I'm sure you're convinced that this is On. And we read the queries and answer them. Like for each query, it's O1. So for M queries, it's M. And so the whole in total, it's n plus m. Now, let's say it's a bit more complicated than this. Oh, also, I said this. Memory is really important also. It doesn't come up here, but you should know how to calculate it. I will not talk about it right now. Let's think about a harder version of the same problem. Again, assume you're given a list of length n. Then you're given m queries. Each query can be one of 2 types. First type is what you already have been seeing so far, sum of a range, basically. So like L at L plus L at L plus 1 plus blah, 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 plus L at R. And but there's now a second type of query, which says change the value of Li for some I. Now, remember our first naive solution which was just for loop in each thing, for loop in each query and find the value, that's going to still work because in one case, you just change the value of L. In the other case, yeah, you naively for loop again and get the answer. Is everyone convinced that it works? Yeah, cool. Now, what about our psum method? Why does that not work? Exactly, least out changes and we don't update psum. So this sum is going to be incorrect. Can we make it work? Yes, you can recalculate all the psum values after each change, but we know that it's going to take ON, which is about as bad as, if not worse, than just calculating the sum from L to R. Does that make sense? Can someone type a dot if it doesn't make sense? Dot. Okay. So what's the problem? psum is wrong. What's the solution? Update psum every time you are updating a value of the list. And let's say you're doing that. How can we do that? The same method as we had here, which we know takes ON. So the approach here is I read input, calculate psum, and then do the queries. If the query is an update, recalculate psum. If the query is getting the range of something, use psum to give answer. And let's examine the complexity of this. So we know reading input is ON, as in reading the list. Calculating psum, as we showed before, is ON. This queries pipe is a for loop that takes n time, and updating updating takes we know ON, recalculating the psum, and using psum takes O1. But remember, you can't assume that these queries will always go to the else branch. You need to, when you're calculating worst time complexity, you need to assume they do the worst thing that they can do, which is this case. So at the end of the day, this is going to be this bad, which is the exact same as our naive solution, which was just looping over values and giving the sum. So it's kind of useless. Great. Now let's think about a new method. I'm not going to let you guys think about it because I don't think you might come up with it on the spot, but here's a hint. Suppose you decompose your array into buckets of size k. So you look at the first k values, you look at the second k values, and so on and so forth. This last bucket might not be of size k, but if n is a multiple of k, then it will be. So let's just right now assume it's a multiple of k, but it's not big a deal. So how many buckets are there in total? N divided by k. Exactly. And again, remember, right now you might be worrying like, oh, floor of n divided by k, ceiling of n divided by k. Don't worry about it. That one off is not going to matter in us calculating time complexity. So what is, I mentioned the size of the last bucket. Okay. Yeah, n mod k, exactly. Well, if it's, yeah, if it's 0, it's k. So let's don't worry about that. Now what you can do is keep track of the sum of each element of the sum of the elements of each bucket. What does this mean? It means that here you had a bucket L0 to Lk minus 1. You can have a variable, for example, called bucket sum. That is the sum of these things at 0. You can have the same thing at 1 be the sum of these things, and so on and so forth. Does that make sense? Also, apologies, this is definitely going to go way over 8. So I'm sorry if you can't stay and make plans. Makes sense. Okay, can you tell me what bucket sum of I is? Or if that's too hard, can you tell me if you have some L of tk all the way to L of, I don't know, t plus 1k minus 1. What is the index of bucket sum for this bucket? No, t. Yeah, exactly. So this would be bucket sum of t. And so now can you tell me what bucket sum of t is? It's when there's a bucket that starts with pk. Cool. So now you do this. How long does it take to compute these sums before the queries? You want to put the sum? Okay, lots of different answers. Okay, what's the cost of calculating the sum of a single bucket? K. How many buckets are there? We answered this already. N divided by k. So how many in total time is this going to take? Exactly. So yeah, everyone cool with this?
So so for each,
So what we want to
each
do
bucket,
is,
so for each bucket, which is n minus k, we're getting the sum of each.
n divided by k, n divided by k.
Mm-hmm.
Calculate sum of those k elements.
Gotcha.
Which we know takes k. So in total, multiply them, you have n. Cool. Okay. There's a huge number of people saying they're following a little bit, but are lost, or they're not following at all. So if you could just you don't need to ask the question, just tell me which part it was so far that is confusing. Also, feel free to talk to me afterwards if you want to talk about it. That's fine too. Okay. Now, let's say we're told to change the value of I, the value of L at I. What do we need to update? Just one bucket. Exactly. So you just need to update L at I itself and sum of new buckets. sum of i's bucket. How long does this take? Okay, that's right. But let me show you a trick. You can do, so let's say T is the value of, sorry, T is the bucket number for I. So I's bucket is T. Then we can do at T is bucket sum of, is whatever it was before, plus the new value, minus the old value. Does this make sense? Yep, okay. Because you're adding the new thing and then removing the old thing and you get what you wanted. So instead of K, it can just take O1. It's not too important, but yeah. Okay. Suppose we correctly know the sum of elements in each bucket. How can we calculate the sum of the range? I will go over this because it's a little bit complicated. So I will just write it down. So you have this, this should be L and R, by the way. Sorry about that. So this is, imagine L falls into TL and R falls into TR. So you have this bucket, L at L is here. There's some stuff here, there's some stuff here. You have some buckets in between, possibly no buckets. Maybe they're even in the same bucket, but for now it doesn't matter. And then you have L at R here. So what is the sum of everything between here? Sum of all buckets, correct. So you need to add all these buckets. So it's the sum of these. But what about the values that fall in here and the values that fall in here? They're not all in this, like they're not a complete bucket, right? There's something to the left of it, something to the right of it, possibly. What can we do? It's not complicated, like don't try to think of a complicated approach. Sum of buckets between them. If you mean sum of elements, then yeah, no, the buckets are these big things, but inside each bucket is all the small elements. So it's like sum of this plus this plus this. L at L plus L at R. Yeah, but there might be some element in here that doesn't go into the next bucket. I will try to give an example. Let's say K is 3 and N is 9. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. And you're given, so your buckets are these. But let's say you want to know the sum of this part. Okay. So the sum of this is in a bucket. So we're good. And you can add 2 as you said, you can add 8 as you said, but what happens to 3 and 7? Exactly. So we are not trying to be smart, just naively add everything. Cool. How long does it take? Okay, let's break it down. At most, how many buckets are in this area? Three in this case, but in the general case, n divided by k, exactly. N divided by k minus 2, I think might be correct, but again, don't care about constants. So n divided by k in between. So we need to loop over those and add them up. How many elements at most are there in here? K, exactly, because in each bucket at most k. Same with this side. And so what you're gonna get is that the O of finding the sum is n divided by k plus k. Okay. Now here's a question for you. What happens when k is 1? Actually, let me make this a new page, because does everyone understand why this is O of n divided by k plus k? Okay, so let me make a new page. And now we're going to talk about how to make this as small as possible. If k is 1, this is O of n plus 1, which is O of n. If k is 2, this is O of n divided by 2 plus 2, and so on and so forth. And when k is n, it's kind of a symmetry, because now it's O of 1 plus n, which is still O of n. Where does the plus k come from again? So these plus k's are the cost of adding the yellow parts. And the n over k is the cost of adding the sum of buckets. Because there is nothing that has the sum of the buckets in it. So like partial sum of buckets in it. Okay, back to here. How can we make this as small as possible? What value of k will make this as small as possible? Just intuitively, I don't really want to prove it. Think calculus if you feel like. Root n, correct. So if you take k to be, it's completely symmetric, so it makes sense that you kind of go in the middle. So if you take k to be root n, you get n divided by root n plus root n, which makes sense because you want these to be as close as possible. And so this is equal to O root n plus root n, which is O root n. Cool? So remember, k wasn't not an input or anything. K was an arbitrary value that we picked, and that's the number of buckets we made. If you're confused, type a dot. Dot. Is your confusion on this page? Okay. So intuitively speaking, whenever you're, I'm just going to explain intuitively, but there's a formal proof by calculus if you want. You want to minimize how big this is. And if you look at the way we're calculating the O, if this one is bigger, that becomes the term of the O. If this one is bigger, such as in this case, that becomes a term of the O. Okay. And so what your goal is to make them equal. One thing you can notice is that their multiple is constant, and you multiply them. So by constant, I mean it's always in. So you want to make them equal. Oh, my bad. And so you get n is equal to nk. Wait, oh, this is supposed to be k. N is equal to k squared, which means that k is squared over. So the rest of the optimal solution is to make buckets with root n. Exactly. That was what I was trying to reach at. And that is why it's called the square root decomposition, because whenever you're doing this kind of decomposition, 90% of the time, the most optimal way is to make your buckets root n. And what is the reason? Intuitively speaking, because usually what one query does is that it goes over the elements of one bucket, and what the other query does is that it goes over all the buckets. So if you have some buckets and you have like this, since some part of the query will be going over one bucket and some part of the query will be iterating over all buckets, you want non-buckets equal a size bucket, which is why you get square root n. Okay, not to tire you out, moving on from why square root n is the most optimal. Oh, sorry, I missed one slide that I made. And this. Okay, I could code it. What if n is not a perfect square? Good question. So I think I mentioned back there that the number of buckets is n divided by k, and k is the size of buckets. I told you that n divided by k is not that different from the ceiling of n divided by k, and so on. So what you can just do is take k to be the floor of square root of n or something. It won't make a change into how the time complexity is, because it's just a one-off and we don't care about constant. Okay. Okay. So I know I went really over time and you're all tired. Technically, kind of the end of the workshop, other than the demo. So if you want to see me do the demo, aka write the code of this, type yes in chat. Yes. Okay. If at least one person wants to see it, I will show it. Stop share. New share. Oh. Can you all see an empty file?
Yeah.
Yes. Okay. So we're going to write it. This is going to be good practice for you if you don't know how to do inputs and stuff in Python. I'm going to write it in an ugly way. The bad thing about Python is the input function reads a whole line. So for example, if the way I wanted to input the list was like this, I would have to do some extra steps. But here for simplicity, I'm just going to assume inputs given like this: 5 size of list, and each element comes one by one. Okay. So also, this is not going to adhere to any CSE 108 thing that you learned that is good practice. And the reason for that is you just want to write code as fast as possible. And if the way that comes to your mind, you know how to do it, it's not looking nice, but it works, I'd say go with that, unless it's really confusing and will cause you to make bugs. So I'm going to define an empty list. I'm going to define n, which is going to be input, and then I'm going to ask type n. Don't give prompts when you're doing competitive programming questions. You never want to print anything unrelated, but I'm putting prompts because it's easier for us as audience to see. So for I in range of n, you want to append. Do we need to do about no? If you by validation, you mean input validation? No, you can always assume input will be given correctly according to the constraints that you're given. So I'm here assuming that the question is telling me that all the all the input is going to be given in a certain format. I don't have an example of the question where you can submit, which kind of sucks, but I do have another example that I can show you at the end if you're interested. Okay, so I'm going to define K. Oops, I need to import math. Okay, the reason I cast to int is it's just rounding it down. No other reason. And so I want to define a bucket index, which is to say a bucket index array, which is going to store the index of each element. You could also do it to the power of 0. Yes, that is right. I could have done that. Oh, well. So this is going to be an array of n elements. It's going to store all the index of each element. So feel free to do your own implementation. If you don't want to look at this, you don't have to. But I think it's good to see one example because it's your first time. So every time, why do I do this? Every time we reach beginning of new bucket, we know that if you mod k, it will be 0. You guys observe this. And the reason I start at -1 is because the 0th element is going to have mod 0. Cool. Now I'm going to set the bucket index of I. And I also want to keep track of a bucket sum. I'm going to initialize it all to 0. And remember, you need to make it k plus 1, because if k is not complete, n is not perfect square, it is possible that k will be slightly small, and so the number of buckets will be slightly bigger. So here we do bucket sum of the index plus equal li. So far, so good. So initialize the bucket index of every element and calculate sum of buckets. Now that we have this, now we need to deal with the queries. So you take an input for the number of queries. And while there's still queries left, we need to do some stuff. So first of all, you need to figure out the type of the query. Assume as input you're given either it's type 1 or 2. So and now you have 2 if branches. If type is equal to 1, which is a sum query, you need to do some stuff. Else, which is the time when update element query, you need to do some other stuff. Okay. I personally think updating the element is easier. That's why I explained it first. So if you remember, you just need to get the index. Oh, sorry, first we need to get the input of the query. So input of the query is one index that needs to be updated. And a value that you want to put in there instead. Now, what you need to do is get the index number, bucket index number of the thing at index. Oh, I just realized I never used this in my thing. Oh, whatever. I guess I can use it. So the B index, the bucket index of I would be bucket index at I. And so now you just need to update the bucket sum. So the bucket sum of that bucket number should be itself plus.
Sorry, what's I in the else statement? Is it, or is it supposed to be in? I'm just.
And thank you. So same logic as we talked about. If the bucket sum is getting updated, add the new value, remove the old value, and then at the end, you just want to update the old value. And then I'm just going to put a print just to make sure that it's like I'm not infinite looping or something for some reason. For the other type of query, you need to get the two indices. So you need to get L, you need to get R, and you want to give the answer, which is a sum. So I'm going to define answer to be 0. And here is a little bit complicated. So what you want to do is traverse from L to R. In the beginning and end, you want to treat it differently because L and R might be not the beginning and end of buckets. So here's me doing the beginning. At first, I want to set I, which is our iterating variable, to L, and then add everything after L that is not in the next bucket. So here I go. While I is less than R, obviously, because I don't want to add extra things. And if I do I mod k not equal to 0, that makes sure that I is not the beginning of a bucket. If it is the beginning of a bucket, we're good. We can use just some bucket. So that's why I have that condition. And so you add Li to the answer and you increase I by 1. Now that we've done that, I don't know if you remember in my slides, but there was a yellow part, the middle, and then another yellow part. This is the first yellow part. Now we're going to the middle. Sum up every bucket in between. So you can do this by making sure, first of all, so you know I is the beginning of a bucket because you only end this while if it becomes the beginning of a bucket, or it is like more than R. What do? You make sure that the whole bucket that I is the first of is still contained in the range that you want to return. And so if it is, you can add that bucket sum to your answer. The index of the bucket sum is in bucket index at I. Cool. And then you add I plus equal to k. Why k? Because you wanted to jump to the next thing that's divisible by k. And here the next one that is first of a bucket. Okay, now that we've summed up everything in between, now you need to sum up everything before R that is not in the previous bucket. And we already know it's not in the I is not in the previous bucket because this while loop terminated. So while I is still less than or equal to R, you add those elements. And then finally, you print your answer. I hope I didn't make any bugs. That would be kind of annoying, but let's try running it. Where have I even saved this? Oh, it's here. Perfect. Cool. Stop share.
Okay, just share the screen a little longer because I just need to type everything.
Oh, I will post these if that helps you out.
All right, thanks.
Okay. Terminal. Can you all see my terminal?
Yeah.
Okay. So I have this square root decomp. Let's run it. Okay, for compile. Just asking for n. Does anyone want to give inputs or should I just pick something myself? 3. Cool. $69. Sure. I hope you're ready to sum those up in your head. $72. Cool. Oops. What did I do? Line 18. Oh, I see where I made the error. If you want to know, on the line that I was checking, I mod K0, I was checking the opposite. So I saved the edit. 69, 420, 72, still error. Yeah, it's kind of annoying. Let me share my whole screen so you can like help me debug. What is wrong in here?
Isn't B index supposed to be or actually, I'm not sure because you said on line 14 you define bucket sum B index, but I'm not sure.
It has an issue with this line.
Oh.
Or sorry, no, it has an issue with the next one. B index. I'll just print some stuff. You can watch me debug and struggle. Actually, I don't need to print that. Okay, let's do this. What? It doesn't even reach this line. Oh my God, why did I put this here? I'm blind. Okay. Sorry about that. I do have the correct code, so I could just copy paste it here and you guys can see, but there is some value in debugging. Still doesn't reach here. I define N, I define K. I think am I in the wrong file? Are there two square root decomps? They are. Oh no. Okay, I have no idea where this one is saved. This is called square root demo. It's here. Unbelievable. Actually, unbelievable. By the way, I haven't been looking at chat. I will check. Thank God. It still has an issue in line 26, but index out of range. Square root 3 is 1, and then 1 plus 1 is 2. That's fine. Did you save? Yeah, that was the problem. I was saving in the wrong file. Isn't the index not defined on line 14? I use B index. That's bucket index, which is being defined here. Oh, I did. Cool. Okay, I want to change this. Actually, I can just print the whole bucket sum and the whole L. There's 3 buckets of size 1. And each bucket has index 0, 1, minus 1 so far. Reach I equal 2, which has B index 1. And bucket sum, which is this one, is defined at 1. Is it L that's an issue? L that's a 10. Okay. B index is 1. It gets increased to 2 if it is thing, which everything K is 1. So every time B index must increase, which it does. And then after it increases, it becomes 2. This is set. And then bucket sum as 2 plus Li at 2 fails. Okay. Oh, why is bucket sum of size 2? Because we make it of size 2. Am I making a logic error here? So square root of 3 is 1. And so your k becomes 1. And your size of buckets becomes your buckets become of size k plus 1. I'm sorry, it's really annoying to watch someone debug something. Thank you for staying. I will figure this out. Bucket sum size bucket is you too. Bye-bye. Maybe I will do this just in case. K is the size of a bucket, so a bucket sum needs to be of that size. Can you show the proper solution? I think my proper solution may have the same bug because I don't remember doing this. Oh, that worked. Okay, well, let's try with 3. 1, 2, 3. And then you can give queries. So let's give it like 1,000 queries because number of queries don't matter. So query of type 2 is updating. So let's do query of type 1 is sum. So let's do a sum first from 0 to 2. The answer is 6, correct? Because 1 plus 2 plus 3 is 6. And you can do 2 to change 1. For example, you change the element at 0 to 10 and you finish the query. Then you can do the first type of query again. And the left side 0, 2. The answer is 15. Why? Because 10 plus 2 plus 3 is 15. Yeah, that was an annoying box. I'm sorry about that. I don't know why I did k plus 1. So let's remove the extra indices. We can do a bigger one. Let's do 10 by 10. Let's just go through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just doing this because it's easy to calculate their sum. Okay, now 1,000 more queries. Type 1, 0 to 9 should be 55. That's correct. Let's try type 1 again with 0 to 8. That should be 45. That's correct. We can do in the middle as well. For example, start at 1 and at, I don't know, 3. That's 9 because 2 plus 3 plus 4 is 9. Now you can change a value. For example, change index at 7, I don't know, to 9. And if you query again, it should be 56 because we just increased it by 1. So query the whole thing. Exactly. Whew. I'm so sorry, guys. But this is correct now. I'll stay if you have any questions, but that's pretty much the end. I will go over some more quick slides. We coded this in Python today. Most of the computer programmers I know use C++. It has a lot of features that C doesn't have, but it's still really faster than Python. So it's great, and I recommend you learn it. And if you know it, makes learning C a lot easier, which is the language I use a lot in upper year. Here's a really cool square root problem. That you guys can do. Feel free to come discuss it with me if you want. And Codeforces is just a competitive programming practice website, which is great. Lastly, I will post today's materials in here. I believe there is a buggy version of the code on there right now, but I will update it sometime quickly. There's the competitive programming handbook. It just goes through a list of algorithms that everyone should know. There's a Geeks for Geeks website, which gives like step-by-step details of some algorithms and their implementation. There's the MCSS Discord, which is the organization that organized this, this workshop. And of course, feel free to reach out to me. So I missed some comments. So optimization of buckets comes from adjusting the size. Exactly. If the sizes were 1, that would be the exact same as our naive implementation, because every time you would update one bucket, which is size 1, and every time you needed to add, you need to add all buckets, there's n of them. Where are these competitions done? Is there a UTM competition? Unfortunately not. I really want there to be one day, but that takes years to plan and stuff. There is a ACM ICPC, and which is like an intercollegiate competition in competitive programming. And that UTSG and UTSC have teams, and I think you're actually allowed to try out and join them. Unfortunately, this is like really beginner stuff. And if you actually want to make it to the tryouts and to the teams or even do well in the competitions, there's a lot more to learn. So most of the people who go into those things are people who already knew stuff from high school. But that's why I want to kind of create this interest in ACM in university, so that maybe students that graduate, that got interested, maybe go back to their high schools as alumni and kind of bring this into high school. I don't know. It's a long way to go. But yeah, that's pretty much it. Thank you so much. So sorry for going overtime. This should have been a 2-hour workshop. But yeah, let me, I'll make an anonymous feedback form on Discord. And I would love it if you guys could fill it out and just give me some feedback. So please join our Discord. And thank you for coming. And sorry, the end was a mess. Bye. I will stay in case anyone wants to ask questions. Are there any websites, books you recommend for competitive programming, problem solving practice? Yes, I linked Codeforces above, like a problem and Codeforces. Send it at around 8:40 if you scroll up in the chat. And definitely recommend going on Codeforces in general and just looking at those. I think a lot of people also use like Demoj, USACO, and other websites. Yeah, feel free to talk about it on Discord. I can give more information. No worries, you're welcome. Have a good day. And I will stop recording.